We're Jacopo and Federico, and today we're going to present wild tests, how to monitor recommender system in the wild. This is a joint project with Bocconi University, Stanford University, Cosa AI, and Coveo. And today, two of the authors of the original library are with you. It's me and Federico, and we're super happy and thrilled to be here with all of you today. What is the problem? Well, if there's one thing we want you to take away from this talk is that evaluating recommender system with the standard metrics that we use both when we do research or in many industrial settings is really not enough. And this is a problem because evaluating recommender system is crucial to their actual effectiveness in the real world. If we just take, for example, e-commerce, which is a field we know very well, 38% of users will stop shopping if there's shown no relevant recommendation. But guessing when a recommendation is not relevant is actually much more tricky than what you think if you apply the standard industry best practice to it. The problem with recommender system, as in many machine learning systems, is that when they fail silently. It's not obvious at all for the model that the model has failed. As you can see here, there's a job post for a CTO, and the suggestion is an executive assistant, which may or may not be a good suggestion. And the results may be even way more dangerous for people that are on this side of the fence. For example, this is a famous case of Amazon recommender system going completely astray and kind of be misled by the behavioral data that was fed into it. Even worse, the feedback that recommender system typically gather in the real world, even when that feedback is positive, may be actually not very telling about how the recommender system is producing a good user experience for the final user. Take, for example, Federico, who really loved romance, and I watched in January The Big Sick. Federico, in the test set, so the month later in February, actually watched When Harry Met Sally. And what we're trying to do here is we have two models to recommend your system, Model A and Model B. And we're asking these two models to predict, based on the January viewing history of Federico, what Federico would watch in February. Both Model A and B guessed correctly. So When Harry Met Sally is actually in both set of prediction for A and B. But as you can see from the other movies in the carousel, there's a big difference in the user experience that Federico will receive. In particular, Model A is much less relevant than Model B, even when Federico will actually click on the same item. So if what we use to evaluate A and B is just a pure quantitative point-wise metrics, like for example, hit rate, we kind of fail to understand the nuances of how this system behaves in the wild. So the question we ask ourselves, and we ask everybody in the field, is, do your tests capture these issues? Is the way in which you evaluate recommender system for research or for production actually able to spot these patterns? A way to solve this problem is behavioral testing. So in behavioral testing, what we try and do is not to evaluate with one single quantitative metrics what happens on held out data points in a test set, which is the standard quantitative way to evaluate recommender system, but it's actually to enforce some input-output that we deem important in the use case at end, and to see if the model that we're trying to evaluate actually respect what we expect from a model solving this problem. Take, for example, this very easy to understand behavioral principle. So irrespective of what's in the test set, what we want to create is some cases in which we feed the model some items. And if the model is trained to produce similar items, we need to make sure that the other items is a substitute item of the first one. So if there's a white t-shirt, we want to make sure that other white t-shirts are suggested as similar and not, for example, pants. Even more subtler, in the case of complementary items, we ask models to actually predict something that is complementary, let's say an add to cart type of recommendation. And while it's a very good idea to suggest an HDMI cable to somebody that bought a TV, it's a terrible idea to suggest a TV to somebody that is buying an HDMI cable. Another principle we want to enforce is to measure how bad a mistake is. If we take pure quantitative metrics like hit or miss, like hit rate, for example, we don't really get a sense of how far we are from the actual truth. And of course, it's a big difference for the user experience when we're trying to predict when Harry met Sally, and model A predicts, Terminator, and model B predicts you got mail. They're both wrong, but they're not wrong in the same way. One is a readable mistake, the other one is a terrible user experience. And finally, we also recognize that not all data points are created equally. This is particularly important in the digital world when consumption is a power law. So you can get a very good aggregate metrics like MRR or hit rate just by optimizing for the most frequent items. But what happens on the long tail? What happens on a subgroup of users, for example, of items that are less used? And we want to make sure that when we deploy something, all these trade-offs are actually made explicit. To solve this problem at scale, we introduced RecList, a package for behavioral testing recommender system. RecList is open source, so everybody can use it for free. It's peer review, has been presented in one of the top conferences in machine learning in the world, and is built by the community for the community. RecList is based on declarative abstraction, very similar, for example, to Metaflow for those of you who use it. You can see here an example of how easy it is to create a test for our recommendation. So you just create a class, you inherit the RecList class, and then any Python function, as long as it's properly decorated, can actually be used to create behavioral tests. And of course, a huge point of RecList is that it comes pre-made with a lot of behavioral tests that you can use on a lot of public data set that you're already probably working on. When you see how easy it is to go from a data set to actually run a RecList, it's literally like 5 lines of code. You just pick a data set, pick a model, you train it if you didn't do it before, and then you run a RecList by supplying the model and the data set that you want to test. RecList can be used for research if you're running a new model and you want to see how this model is performing, not just based on pure quantitative metrics, but also on behavioral ones. Or of course, you can use in production system. For example, in your CI/CD, before promoting a model to deployment, you may want to test not just its accuracy, as in standard practice, but you may want to test, for example, if the behavioral principle about complementary items is actually respected or not in your model. So what now? RecSys has been released as an alpha a couple of months ago and has been presented to some teams in some of the best recommender system shops in the world to collect feedback. And this is part of one of the first public talks they were having to start discussing RecList and the problem of behavioral testing recommender system among the broader public. We're actually planning right now a beta version of RecList, which will incorporate all the feedback that we received so far. What can you do? Well, check out RecList on GitHub. And if you like this talk, or even if you didn't, give us a start and start spreading the good news about how to use behavioral testing for recommender system. And of course, if you try the project or read the paper and you really like it and want to contribute, please get in touch, as we will need all the help from the community to build a better and improved package for the beta version of it. Thanks so much for being with us today, and we'd love to answer any question you may have. Thank you. Ciao.
Cool. So for those of you that have questions, we've got Federico here to answer live, and we have a few minutes. So I'll start fielding questions as they come in. Feel free to let us know what you've got. And Federico, while we're waiting for someone to ask a question, I should say, we've got one. So can you give practical examples for tests?
Yeah, sure. I think that like one of the most important tests, like the idea that we want to embed in RecList is this kind of behavioral test. And Jacopo made an example of this, the example of suggesting an HDMI cable to someone that buys a television. That makes a lot of sense because these are two complementary items. But if instead someone is buying an HDMI cable, it doesn't actually make sense to suggest to this person a television, because probably he already has somehow the television. So what we are trying to do is like to work in a direction in which we can use the metadata inside our data sets to actually work and find a way to define this behavioral test and provide somehow a more broader evaluation of our models.
Yeah, makes sense. We've got the GitHub link. Someone is asking for it. It is right here. I'm going to throw that in the Slack. All right. So I really want to know, like, what's the idea with RecList? What's the end game here? Are you thinking that you want to create a company out of this, or is it just something that you see pain in the market and you would like to ease that pain?
I think it's closer to the second one. So we are actually working on this open source project, and we want to keep it open source so that everyone can like somehow use this in production, but also for research. So we have like these two kind of souls in which we want to make it useful for research. So for evaluation of like recommender system in research, but also as a plug and play tool you can use in production to support your system and evaluation.
Yeah. Okay. Nice. Is RecList only for recommender systems, or could I use it for any predictive recommendations that I do?
Currently is based mainly on recommender system, and we have embedded some use cases like session-based recommender system. We are working a bit on like developing more the foundations. This was the alpha, and we are like trying to improve this on the beta. So we collected a lot of feedback that we're trying to implement and to apply to actually improve the system.